In your notes, there are several ways of finding the factor number. I'm going to focus on the second way in this video. We will use the equation of the second way, no matter which way we find the factor number, to do many calculations. So I find that using this equation for all parts of the factor number to be most helpful, but you may use any part that you want. So we have a relationship both in our packet and in our PowerPoint presentation. Dose varies directly to rate. I'm going to use D for dose. Varies directly, I know, equals K times, and I'm going to use R for rate. Dose is in milligrams or micrograms. It is the weight of the medication. Rate is in milliliters per hour because we want to give the med with an infusion pump. So we need to find an example where we know both the dose and the rate. Most of the time, we'll know these two quantities for the minimum because that is the first calculation we did for this problem. We want to make sure that we use unrounded numbers. So if we go way back, we found that the minimum milliliter per hour rate to be 4.23 mLs per hour. We rounded it to 4.2, but we want to use that number that we recorded as 4.23 milliliters per hour. We started that problem with a dose, the minimum dose, of 2 micrograms per kilogram per minute. Now, if you remember, in variation problems, we don't put the labels in. So I know that this amount with the weight is the dose, and I know that this that I would set on the IV pump is the rate, and I'm just going to substitute them into the formula. So I have 2 equals K times 4.23. And I have a little algebra equation. One step solves it, so I divide both sides by 4.23. And I get K is equal to 0.4728, and it continues. Now K will always be rounded to hundredths, and that is in your packet on titration. So I'm going to round my K value and have K is equal to 0.47. Knowing this K value is going to save me so much time because I don't have to set up the entire list of conversions using dimensional analysis for every problem or for every row of the chart. Instead, I can keep using this formula. So this formula is super important. I can plug in either the rate or the dose, whichever I have, and I can use this K value. This constant is good for all problems where I have the same patient. As soon as I change the IV bag to a different dosage strength, I change to a different med, or I change to a different patient, I have to calculate a new value for K.